Hello friends, welcome back to our channel Codes and Standards Academy. Today in this video we are going to learn about the limits, fits and tolerances. Let's get into the video. Before going to the topic, let's learn few types of dimensions and sizes. Firstly, mating dimension. Surfaces which are in contact when mating parts are assembled, those are called mating dimensions. Similarly, surfaces which are not in contact when mating parts are assembled, those dimensions are called free dimensions. Coming to the types of sizes, firstly we have a design size. The dimensions arrived at during designing the product, usually as a result of calculations by taking various factors into consideration such as load carrying capacity, fracture resistance, etc. These design sizes have lower limit and upper limit. Basic size. Basic size is the theoretical size from which all limits for the dimensions are given. The dimensions obtained after machining or filing a part is called actual size. The actual size should be within the permissible limits. Coming to the limits. Limits are two extreme permissible sizes of a given dimension. The highest permissible size is called a high limit. Inversely, the lowest permissible size is called low limit. Limits are given on a basic size. Allowance. Allowance is the intentional difference between the hole diameter and a shaft diameter to achieve a desired fit. Allowances are of two types. Maximum allowance, that is the difference between maximum hole diameter and a minimum shaft diameter, and a minimum allowance, which is a difference between minimum hole dia and maximum shaft dia. Clearance or positive allowance. When the hole diameter is bigger than the shaft diameter, then it is called a positive allowance or clearance. As you see, there is a clearance between the shaft and the hole. Interference or negative allowance. When the shaft diameter is bigger than the hole diameter, then it is called negative allowance or interference. Tolerance and deviation. The algebraic difference between a high limit and the lower limit is called tolerance. Tolerances are of two types. One is unilateral. Here the tolerance lies only on one side of the basic size. If it is a bilateral, the limits of the tolerance lie on either side. That is, in other words, we can say it's a plus or minus on both the sides. Deviation. The algebraic difference between the actual size and the basic size. Upper deviation and lower deviation. The difference between maximum size limit and the basic size. A lower deviation is the difference between the minimum size limit and the basic size. Tolerance zone. It is a zone bounded by the two limits of the size of a part to be manufactured and is defined by its magnitude and its position in reference to the zero line. Zero line. The zero line is the line of zero deviation and it represents the basic size. Coming to the fits. Fit is the degree of tightness between mating parts. It can be expressed as a relationship between the dimensions of two mating parts before their assembly. Fits are of three types. Let's learn each one in detail. Coming to the clearance fit. The limit of mating dimensions are so selected that if the parts are made within the limits, there will be always a positive assembly between a mating parts. As you see in this picture, we have always given some space on both the sides, that is called a positive allowances. Examples: fitting of shaft in a bush bearing, ram of a shaper machine on its guided ways, gear on a spindle shaft. Types of clearance fit: we have slack running fit, loose running fit, easy running fit, normal running fit, close running fit and precision running fit. And let's learn each one. Coming to the slack running fit, the dimension of a shaft should be small enough to maintain a film of oil for lubrication. It is used in a bearing pair. Loose running fit. It is used between those mating parts where no precision is required. It provides a minimum allowance. It is used on loose pulleys and agricultural machineries. Easy running fit. There are a few applications. Sleeve bearings with medium revolution, grease lubricated bearings of wheel boxes, gear sliding on shafts, sliding blocks. Normal running fit applications: sleeve bearings with high revolution, bearings on machine spindles. Close running fit applications: we have sleeve shafts, clutches, movable gears and gear trains. Precision sliding fit. The applications are in milling cutters on milling mandrel, sealing rings and bearing cover. Interference fits. A fit which provides an interference is called interference fit. In this case, the limit sizes of the hole and shaft are so chosen that if the hole and shaft dimensions are made with specified limits, the shaft dimension will always be bigger than the hole dimension. Interference fits are of three types. One is a shrink fit, medium force fit, and a tight fit. Shrink fit. It refers to the maximum negative allowance in assembly of a hole and a shaft. The hole is expanded by heating and then rapidly cooled in its position. It is used for fitting of rims. Medium force fit. These fits have negative allowance. Considerable pressure is required to assemble a hole and a shaft. It is used in car wheels, armature of dynamos, etc. Tight fit. One part can be assembled into the other with hand hammer or by a light pressure. A slight negative allowance exists between two main parts. It gives a semi-permanent fit. It is used in key pulleys and shaft and rock ram. Coming to the transition fit. A fit which may provide either clearance or an interference is called transition fit. In this type, the tolerance zone of the hole and the shaft overlap. So we can't predict whether it is of clearance or interference. So the allowance in this case may be negative or positive. Example are fittings of anti-frictional bearings. Types of transition fit. We have a push fit, light keying fit, medium keying fit, and heavy keying fit. The various fits are obtained from two systems. One is a hole based system. In this system, the clearances and interference are obtained by associating various shafts with a single hole whose lower limit or lower deviation is zero. Here, the size of the hole kept constant. By varying the shaft sizes, we will get different fits. The another system is a shaft based system. In this system, the size of the shaft is kept constant. The size of the hole is varied to get different fits. If you have any doubts in this topic, limits, fits and tolerances, you can write in the comment box. And if you need any specific video on any specific topic, you can write in the comment box or in post the comments in our LinkedIn page or Instagram. If you found this video useful, kindly like this video and share it with your friends and engineers, and subscribe to our channel Codes and Standards Academy. And finally, thank you for watching.